Hi everyone, welcome to this episode of Keipert Labs. A quick how-to today to give you some further guidance on how to do calculations involving percent composition by mass, and then this concept that we are now calling empirical formulae, which will actually feel a bit familiar from what we were doing in our last activity. Okay, so this kind of we're going to go through some of the practice questions on the worksheet that goes with this. Okay, so what we're looking at is this idea with percent composition by mass. Okay, so percent composition, we're looking that is mass of the element over the mass of the compound times 100%. Okay, that's the sort of formula that we're working with here. Okay, so I'm going to keep that there, so I might bump this down so that we can keep that there. Okay, so what we're told that we've got a sample of sucrose, table sugar, 20.0 grams of it. That in making careful measurements of mass, that what we've worked out is it's 8.44 grams of carbon, 1.30 grams of hydrogen, and 10.26 grams of oxygen. Okay, so the first thing that we're looking at is the ratio of the masses of each element to the compound itself. Okay, so we've got 8.44 over 20.0, 1.30 over 20.0, and 10.26 over 20.0. So those are the ratios that we have. Okay, and so then now what we have to do is we then have to work out what they are as a percentage. So then essentially all we're doing is multiplying this ratio, the mass of the element over the mass of the compound, times 100. Okay, so we get 42.2% for carbon. We get 6.5% hydrogen and 51.3% oxygen. Okay, so these calculations are actually really simple. Okay, students have struggled with them in the past purely just because I hadn't really taken a moment to actually give them a little bit of a hand as to what you actually do. But so you're just looking for the mass of the element over the mass of the compound times 100%. Gives you the percentage composition. Okay, what we're going to see as we get into our next unit, where we start to introduce some extra concepts, that we can look at this percentage composition without ever having actually done any direct measurement of that compound. Okay, all right. But so you should be right now to go through some of those calculations here. Okay, but so now what I'm going to do is I'm going to give you a bit of guidance about what we call our empirical formula. Okay, so now we're just going to introduce this term of empirical formula, which is actually giving a more technical or chemistry kind of label to what we were doing in our previous activity, where we were using mass ratios to determine what the formula should be. And so the empirical formula for a compound is the simplest whole number ratio of elements in the compound. Okay, and so we're basing that off mass measurements. Okay, just like we were doing before, we're basically doing some further practice on the same kind of activity. Okay, looking at the mass ratios to help us to work out, well, what's the simplest formula we can come up with that would account for those mass ratios. Okay, so let's look at question 6 here. So we're told that two compounds containing hydrogen and oxygen. Compound number 1 is measured to have 15.0 grams of hydrogen and 120.0 grams of oxygen. Compound 2 is measured to have 2.0 grams of hydrogen and 32.0 grams of oxygen. Okay, so then what we can do is we can look at, all right, well, what's the ratio of hydrogen, of oxygen to hydrogen in these cases? Okay, so here what we've got is we've got 8 to 1. Okay, and here we've got 16 to 1. Okay, so just as we've identified before that they're not the same, okay, which suggests that there's more than one possible compound here, that these aren't the same compound, and because this ratio is, so the ratio of compound 2 is double that of compound 1, that they're combining in different ratios. Okay, so different. Okay, so that we're seeing that we've got different ratios of oxygens to hydrogens in compounds 1 and 2. Okay, so we're told then, alright, saying that if compound 1 is actually water, H2O, so that our oxygen-hydrogen ratio here represents that, and then we're saying, alright, well, what's the logical answer for what compound 2 could be? So that we're seeing that we've now got a ratio of double the hydrogens, double the oxygens for the hydrogens. And saying, alright, well, let's, so we're going to end up with twice as much oxygen. And so we end up with this compound, which is called hydrogen peroxide. Biologists might take note here. Okay, hydrogen peroxide, H2O2. Okay, so what we can see here is, just as we did before, we're using the mass ratios and the relationship between compounds, between two different compounds, to help us give us information on what the simplest ratio formulas could be, and then seeing that from here to here, then that allows us to say, right, well, we've doubled the mass of our oxygens. The oxygen atom itself hasn't doubled, but we have twice as many of them, and so that's our next logical answer. Okay, so you can go on and complete that next practice question where you're looking at nitrogen and oxygen in 3 different combinations. Okay, using the same kind of logic, looking at ratios, looking at how one compound compares to another. Okay, thanks very much for watching. Time for another science joke. Alright, this one's an oldie but a goodie. 2 chemists walk into a bar. The first chemist says, I think I'll have an H2O. The second chemist says, I think I'll have an H2O too. And he died. Thanks very much for watching. Bye for now.